Okay, as we're looking at these goals, some of you might say, yeah, I already can do these goals. Why are we here? Hopefully we'll build them a little stronger. So let's start out just by doing a little exploration. You'll notice that the graph, or the equation of the line is there. What I want to do with each of these, though, using the graph, I want you to find what the y-intercept is, in this case. Right, the y-intercept is at the point 0,5. And I want you to calculate the slope, and we can do that in one of two ways. Slope equals rise over run. And all that rise means is change in y over change in x. You guys familiar with that change symbol, delta triangle, which means change in something? And the way we can do that mathematically is by going y2 minus y1 over x2 minus x1. So what that means is if you take 2 points and you subtract the y values and then subtract the x values, you'll find the slope. So let's take a point here, maybe this one, for example. And this is the point 5 and 15. So there'd be sort of two ways to do this. One is count rise and run, which is actually not that hard in this case. Find here, find here. The run is 5, the rise is 10. Right, so if it's rise over run, in this case, m equals rise over run. 2. Or if you wanted to try using this formula, all we would do is we would take, let's label these like this one x1, y1, this one x2, y2, right, the x point then the y point. So we could go y2 minus y1, so that ends up being 15 minus 5, oh yeah, that's that 10. And x2 minus x1, that's that 5 minus 0. So we would end up again here with 10 and 5. So we see how here, either using rise over run or using the slope formula, in either case, our slope is 2. Okay, so state the y-intercept. The y-intercept was 0,5, or the point, or the y-intercept was 5, and the slope is 2. Okay. I see that this is 0,1. When I'm looking to find the slope, generally a good practice of something like that is just pick another point that's actually going through intersection. Right? Like, sure, you could probably do this at, say, like this point or this point, but you're not quite as precise there. Like, this is somewhere between 2 and 3, but I don't know exactly what it's at, right? So I would say always try to pick a spot that's actually hitting an intersect in the graph. So this one here is the point 3, 10. Okay, give yourself a moment to try to find that slope. Find the slope of that graph. Seen a match? You might be starting to see a bit of a link here. Maybe, perhaps, hopefully. Try another one. This one, I see there's this spot here. This spot here is at the point 0,9. Or you could say the intercept is at 9. And let's see, where's a point that goes to the intersection? That looks like one right there. That's the point 1, 5. So if I was doing my slope formula here, m equals y2 minus y1 over x2 minus x1. So I'll say 5 minus 9 over 1 minus 0. I end up with negative 4 over 1, which is the slope of negative 4. And you may have been able to just count that, right? This is up 4 over 1. Negative, nice. This has been the adventures of slope. Yeah. So once again here we had a slope equal to negative 4 and a y-intercept is equal to 9. Rock is almost disappeared. Soon she will become part of the brain. Sure. Okay, I think we can leave this last. I think we're starting to get it. Okay, so in this equation, if we called this y equals m times x plus b, which is generally the format we'll use, this value here is the slope. This value here is the y-intercept. So without even doing much with this graph above, we could say, oh, I know that on this graph, the slope is negative 2, and the y-intercept is at 5. Right? That's what that equation is telling me. Y equals mx plus b, slope and y-intercept. Good? Okay. So let's figure out the equation of this one. So if y equals m times x plus b, and I know that this one will be slope, and I know this one will be the y-intercept. Why don't I first of all find the y-intercept? Y-intercept is at 0, 4, or my b is 4. So I know that y equals mx plus 4. Now there's two things we can do here. One, we can find the slope, and that's what we'll just calculate. But another thing we could do is if we just have another point, like for example, I see this point up here. This is a point that has an x and a y, right? This is the point 10, 14. If I've like forgotten how to do slope or something like that, and clearly I've also forgotten how to write that 14. I could just substitute this in, x, y, and that would find my slope also. But I'm going to here just find my slope formula, m equals 14 minus 4 over 10 minus 0 equals 10 over 10, slope of 1. Oh, and yeah, we can actually just see that. Every time it goes over 1, it goes up 1. Over 1, up 1. Over 1, up 1. Right, that's all that slope really means, is that it ends up being 1 for 1 every time we went over. So our equation is y equals 1 times x plus 4. Or we could even say y equals x plus 4, right? When we have a coefficient of 1, we don't actually have to write it. So y equals 1x plus 4, or y equals... Look familiar? No, I've never seen this before. Hope that's not the case. This should be one of those review topics. Just going back a few years. All right, this one. Y-intercept. So y equals mx plus 7. Right, 7 is my y-intercept here. Now I just need to find my slope. Now, if I don't want to do any fancy math, why don't I just count how far it goes over every time? So in every time it goes 1 over, how far does it go down? It goes down 2. Let's check again. Down 2 over 1. Down 2 over 1. Down 2 over 1. What's my slope? Yeah, -2. Right, and we could check that with another point, but I'm pretty confident here that as it goes down 2, it goes over 1. It goes down 2, it goes over 1. So our slope is -2, y equals -2 times x plus 7. How low can she go?
The question is, can she get up?
Yeah, with a backpack on, hey? Someone put a brick in that backpack, then we'll see. Okay, in this case, what's my y-intercept? Nice. So I know that y equals mx plus 0. That seems a bit redundant. Y equals mx. Okay. And I see another point here. You'll notice I'm kind of switching how I find slope. You can do it by counting, you can do it by slope formula. I'm just going to do both, so we're kind of comfortable either way. Not really too worried, though, if you're just doing one of them. It's fine. Take a moment here. Try to find the slope of this. Some of you more intuitive ones may even notice if it started at 0, 0, and it gets up to 412. You might actually know what the relationship is in terms of slope. As it's gone over 4, it's gone up 12. That may tell you what the slope is. Y equals 3x plus 0. And we talked yesterday about partial linear relation or linear equations or direct linear equations. This one goes through the origin, goes through 0, 0, so it's direct. Right? The ones we did yesterday, when they have a y-intercept, those are partial. They do not go through the origin. But this one, y equals 3x. Whatever x is, y will be triple that. Cool? All right. What about this? What about if it's slightly more interesting? Now, money, money, money. Christelle is earning some money. This looks like a pretty profitable enterprise for Christelle. She's babysitting on the weekends. The kids are brats, but you know she likes them, so no problem. Start out. State the y-intercept. What's the y-intercept here? How much money does she make if she works 0 hours? That's what it's asking. Oh, poor girl. Suppose that makes sense though. It would be a bad deal if I had to pay the babysitter for them not coming. So it's probably worth it. Now calculate the slope. What we're really asking is, as it goes over 1, how much is it going up by? Right? That's what slope is asking. You are probably also noticing this is clearly a bit of a stretched y-axis, right? The x-axis goes 1 every time the y-axis goes 20 here. So the slope is actually 20. And if you wanted to check this, we could have done a spot like this. This is the spot 9 and 180. So y would be 180 minus 0, the origin, over 9 minus 0, which ends up being 180 over 9, which is 20. Sorry, I said y. So now we've got this set up. So what does the slope mean in this case? What's that tell you? Can you tell anything about if you would want this babysitting job or not based on the slope?
Yeah.
Yeah. Well, what's it tell you? $20 an hour. It's pretty easy value, right? I guess it depends how good the kids are. But so yeah, she's making $20 per hour. And this is a little bit of a note here. On a graph, the slope, that always tells you some rate of change. So if instead my graph was saying, you know, this many hours, this many kilometers from Edmonton, or something like that, right? It's me driving to Calgary, or maybe more interestingly, my sister lives in Ohio, so maybe I'm going to visit my sister in Ohio. So amount of hours, amount of kilometers away from Edmonton, then what would the rate of change tell me there? What would the slope tell me there? If it was hours and kilometers, what would the slope tell me? What's that?
You just say it from class.
I was kind of wondering, maybe you could share it with everyone. Eh?
I think then you lose them for.
If this was hours, that was kilometers, we'd be talking kilometers per hour, right? It's just a rate between you. So in this case, it's dollars per hour. But if this was kilometers, it'd be kilometers per hour. Or if this is like pizzas consumed per hour, right? Or whatever the graph is measuring, it's y divided by x. That's what the slope is. Okay, back to our friend the plumber, the very profitable plumber, we might add. So Okino is owning this plumbing business. He charges his flat fee plus whatever his hourly rate is. So let's take a look here. What's the y-intercept first of all? The y-intercept here. Do you know that for sure?
No,
I'm guessing it's something like that too, but I'm not really sure actually. I'm not really sure here. I think it's going to be 80 or 90 or 70 or 86 or 72 or somewhere in there. I don't know exactly. 90 is a great guess. I don't think I should just say a guess though when I'm charging this as my plumbing flat rate, right?
Yeah, I don't want to.
So maybe we should find some spots that are actually intersects here. I wonder if we have any. I see this one. And I see this one. Okay, so I see two that are actually intersects at points. There's this point which is 7 and 900. And there's this one which is 2 and 300. Okay, so I think I can find slope, let's say. I can start with slope. Okay, a little bit lower. So m equals 900 minus 300 over 7 minus 2. I was observing one of my earlier classes was really struggling with slope. This is something we're comfortable with, yes?
Yeah.
Okay. It's just that minus that over that minus that. The over means divide by. So this ends up being 600 over 5, which is 120. So the slope is 120. Okay. Now, do you think I could use this to find b? Find the y. I know that y equals 120 x plus b, but I still don't know b. What would you think if I took one of these points, maybe that one, and substituted in as x and y? Then I'd be able to pretty comfortably find b. Then I know that it's not just a guess. So if I know that 300 equals 120 times 2 plus b, or I know that 300 equals 240 plus b. Now do I know what b is a little more comfortably here? By the way, I know we've been taught to do this last step, subtract 240, subtract 240, but probably by looking at this, 240 plus something is 300. Probably don't actually have to write that out. You know what b is already there. Yeah, b is 60. B is 60. Which, I have to tell you, isn't what I would have guessed. I would have guessed that it was a little bit higher than that. Which maybe tells me actually that it's possible that the other points are not exactly through. But I think this is as good of precision as we can get. So the b value here is 60. Okay, so what do these mean in this case? Well, if he works 0 hours, he still makes $60. So $60 is his flat. Okay, that's the first thing I see. And then his slope is 100 to 120. Now, if we're generally saying slope is the rate of change, in this context, what does the rate of change mean? If this is earnings, this is hours, slope will basically always be this over this. So what's the unit for earnings? $120 per hour is hourly rate. Yeah, I don't have to do that easy. I can write hourly. $120 is his hourly rate. Pretty profitable. Like we said yesterday in this plumbing business, there probably are some extra costs that we're not thinking about initially. He's probably not taking home money from an hour. I imagine he's paying for a lot of costs. Cool. Now, today, you do have time. I kind of suspect that just like yesterday, a few of these questions might take you a bit of work. We're not going to move on to the next lesson today. We're just going to stay with working on this. Why don't you guys start? I kind of think the first part you find pretty straightforward, but as you get going, Jack and I'll except for the lazy I'm big here.
This is one, two, three, pick up.